Hello, everyone. This is Mr. Couple. I'm joined today with my IB Physics Year 2 class. We got like a big showing today, like looks like 10 people in the voice chat. So everyone say hello real quick.
Hello.
Howdy, this is
Hi.
Alex.
Yay, it's all of my favorite students all in one place.
Kelvin's here.
I really miss you guys a lot. I'm glad that you can come and join us today. It's really exciting for me. Okay, no one's going to say anything. Now I feel awkward. All right, so
Miss you too.
thanks. Today I'm going to be talking to you guys about energy sources. After last lesson, I was like, why am I just jumping right into all this math? I should be giving you like these sort of big picture, broad discussions, and then we can like focus in and do all the math stuff. So I just want to spend today kind of talking about renewable energy, non-renewable energy, primary energy sources versus secondary energy sources, and then we'll get into the more like physics and math calculation stuff like that next week. So I have three main ideas that I want to teach you guys about today. They are, here we go. So when primary energy is processed or exploited, secondary energy is produced. The second main idea is that non-renewable sources of energy are finite sources. They're being depleted faster than they can be produced, and so they'll run out. And then the last thing is that I want you to know some sources of renewable energy, like solar, wind, wave, tidal, and hydroelectric. Those are the ones that IB mainly concerns with. There's also geothermal, but we don't really go into that in the IB curriculum. All right, so those are my three main ideas for the lesson today. We're just going to get started. So first, let's talk about primary and secondary energy. So I don't know if you guys ever heard this before. Most people don't talk like this. This is like a purely like IB physics thing. So there are two, basically you can say there are two types of energy. So there's primary energy, which is the energy you find like raw in the environment in nature, and then there's secondary energy, which requires processing of the primary energy. So for example, here's some pictures. So the energy that you put in your car is gasoline, but gasoline has to be produced or manufactured or refined in a facility. So before you can put the gasoline in your car, you have to refine it. But what does the refinery need? Well, it needs crude oil that comes out of the ground. So which of these here? So this is the crude oil. This is gasoline. I can't even read any of this. Let me try using a brighter color. Maybe that'll work. So over here, I can't read that either. But I like write it on here. Here we go. Crude oil.
Keppel, use black.
Black. Oh my gosh, I should use black because this is okay. Here we go. So this is crude oil. Yeah. Crude oil, and then what color over here? Green looked like it was working pretty good. This is gasoline, and then down here we have what's called the refinery. I don't know how to spell refinery. Refined. I'm just gonna write refined. Okay, so which of these three is the primary energy? You guys just want
Crude
to
oil.
jump in. Crude oil. So crude oil is your primary, and then we process it at a facility, and then it becomes what is gasoline called?
Gasoline.
What do we call that?
Secondary.
Secondary. So generally the secondary energy is what we're actually going to put in our machines, because you can't, like, machines don't operate off of the primary energy. They need some sort of like processed form of energy in order to operate. There is, however, some exceptions to what I just said, but generally speaking, secondary energy is like going to be useful, like we can use it, and then primary energy, you have to do something to it in order to make it exploitable. Like you have to exploit it and process it. What questions do you guys have for me about this?
What does the do you know what the process looks like? Like in
For
terms of
for
refining?
refining it. So
Like
I know
what
what I think happens is they have like these big stacks, and I don't know which one it is, but there's those stacks, and then what happens is when you fill it up with oil and then you heat it, you end up getting like different layers of fuel that end up sort of separating out, and then you just kind of pipe those out. And so a one layer, is like the gasoline will come out of one side, and then like diesel will come out of another. I'm not really sure on the specifics of that, but you get like it sort of separates itself out through this process, if that makes
oh,
sense.
so that's the difference between diesel. Okay.
Right, yeah. So gasoline and diesel are all coming from crude, but you're getting like these different at different heights within the fluid as it kind of like I don't know what the word is, but it does all this weird chemical stuff. It ends up like separating at different layers.
That's pretty cool.
It is pretty cool. There's if you want to be, the only reason I know this is from playing modded Minecraft, because there's a Minecraft mod where you actually have to build a refinery and you get all these different things out of there. And I was wondering about how accurate it was, so I actually went out and looked it up, and yeah, they got it right. What other questions do you guys have?
Is there a way to misrefine something, like refine it incorrect?
Yeah, I think you can. Like if you don't raise it to the proper temperature, you can like mess it up. Yeah, there's lots of things that can go wrong. It's a really exact science, so to speak. Like you gotta have the correct equipment in order to do it. So that's pretty basic stuff, right? You just primary is what you find in nature. It hasn't been exploited yet, and then secondary energy has been exploited. Humans have processed it in some way and altered it. So here's an example. A windmill is used to grind grain into flour. So I'm going to show you guys this video. Ooh, I didn't set up my video settings. This might not work. It's going to have to. Oh, here we go. Okay. Okay, so I don't know if you guys ever seen like an actual windmill operating before. So the windmill is making grain, or it's taking grain and making flour from it. It's like grinding it up through that mechanical process. So I want you guys to discuss, and I'm going to kind of stay in the background here. I want you guys to discuss through the voice chat primary and secondary energy sources as it relates to grinding wheat in a windmill. If you guys could just jump in and start a discussion.
So like I think it starts with the wind being the primary source.
Okay, so the wind is the primary source, which transfers into the mechanical energy of the middle of in the inside of the windmill, which turns the wheel or flour to be, which allows the flour to be ground down, not flour, wheat, and then to be used.
Would the secondary be though?
I think it's
The
just
mechanical energy.
right? Sort of goes back to like the secondary energy being what we use and the primary energy being like the thing that we get the secondary energy from.
Yeah, you guys nailed it. That's exactly right. So the wind would be the primary energy in this case, and then the machinery of that mechanism of the wheel and the gears and everything turning that mechanical energy, and then we're using that energy to then do work. So that would be the secondary energy source. Yeah, so I thought this one was a little weird because it wasn't kind of it's really different than the oil example, right? Because you have this like actual machine, this mechanism that's utilizing the primary energy, the wind, directly grabbing it and turning it into this mechanical energy. I'm trying to think if there's anything else. Oh, so what else could we have done? Like, so this is an old-fashioned windmill. Like we've been using this for centuries. What could we do in like modern times? We wouldn't just grind flour with like this wheeled gear machine. What could we do with this mechanical energy from the wind? What could we do with this instead? Like we can go to another place. What could we do with it in modern times, or what do we do with it in modern times?
Turn it into
Transform it.
electricity.
Yeah, you make electricity out of it. I'm gonna run out of space. And electricity there is a secondary or a primary source. So is electricity a secondary or a primary source of energy?
Should be a secondary because we use it to do other stuff.
Yep. Electricity is always secondary.
Unless it comes directly from a lightning bolt.
Ooh, interesting. I hadn't even thought about that. That's a good point. Whoa, you're just blowing my mind there, Colin.
It's a primary and a secondary energy source, depending on where we get it from.
Yeah, that's a good point. So electricity, as it relates to transmitting it through power lines, that's a secondary source. And then technically fuels are as well. Think about this. Like The secondary source is what we distribute. Like we create distribution networks for gasoline. Like we have gas stations, we have tanker trucks, we have pipelines that carry it all around the globe. We also have distribution systems for electricity, like power lines and transmission cables that carry it all around the globe. So the secondary source is the one that you're going to be sending out to people that we're going to be utilizing. Cool.
Indeed.
Yeah.
Okay, let's talk about classifying energy sources. So there's two classifications of energy sources, and they're very broad, and you guys are all familiar with them. You've heard these before. So there's non-renewable, and then there's renewable. So those are the two classifications. These are really large classes, but basically we say an energy source is either non-renewable or renewable. And it's kind of funny because it's just like, one is like it's this and the other one is not. So it's pretty obvious. It's like easy. It's either renewable or it's not. Well, but let's be careful with what do we mean by non-renewable. So renewable makes sense, right? Like it replenishes itself, like it comes back. But non-renewable, because it's weird. It's like technically everything is non-renewable because the universe is going to end. Like we're eventually going to run out of everything. Like entropy is going to take over the heat death of the universe. So technically there's no such thing as a truly renewable resource. So we have to be precise in how we define what we say is a non-renewable source. So basically, the idea is that non-renewable sources are finite in the sense that they're depleted faster than they can be replenished. So we are extracting energy from this source faster than nature can replenish it. And so all other sources are classified as renewable. So let's look at some examples. So what are some non-renewable energy sources? You guys can just shout them out and I'll write them down.
Nuclear.
Oil.
Coal. Any fossil fuel, just
Yeah, so we could put both these together and say fossil fuels. Are there any others you guys can think of?
wood.
Wood. Is wood non-renewable? Depends. I'll put a question.
Well, I feel like we would deplete it faster than we could replenish it.
If we tried to generate all of our electricity off wood, yeah, for sure, right? But it's kind of right. It depends. Like how much are we using it? If we're just using it a little bit, I guess technically it would be renewable. But if we're not using it, I don't know. If we're using it like a ton, yeah, it's not going to be. So wood kind of like can go either way. It just depends, right? I mean, all of these technically, you can make an argument that they could go in one or the other category. Generally speaking, the way we're using wood today, I would probably say it's renewable, but back in the early 1800s, you would classify it as non-renewable. Before we had all the oil boom and everything, we used to get all of our energy from burning wood, and that was definitely non-renewable then. Like we were cutting down forest faster than we could replant them. But now there's a lot of land management knowledge that we have, and we are sort of able to control that better. But we also don't really use wood to generate power anymore. How about some renewables?
Solar.
Solar,
Geothermal.
geothermal,
Wind.
wind.
Hydroelectric.
Yeah, let's just call it water. So water will classify like all sorts of stuff. So there's hydroelectric, but there's also tidal. So you can get when the tide comes in and tide goes out, you can use that energy. That's from the moon, right? We talked about tides when we studied gravity. You can use that tidal flow to generate electricity as well. So I'm just going to call water as like all those things. I think that's it. I think you guys got them all.
Question. I just realized
Mhm.
the solar panels get energy from the energy they absorb from the sun, right?
Yep.
Wouldn't it make more sense to make them a darker color so they absorb more energy?
Yeah, I mean that's a good question. So we're gonna talk a little bit more about this, but I'm trying to remember how this works. It's like the different frequencies have different output from the sun, and so you actually don't want them to be black. There's certain it's like a weird spectrum like distribution like this. It's called like the black body spectrum or something like that. I'm drawing it wrong. It's more like that. It's wider, it's fatter to the right side. But the idea is like you want to try to grab those like peak. This is the frequency down here, and then this is the intensity up here. And you want to try to grab like the colors at the peak, if that makes sense. And then if you do make it all the way black, like I don't know. But yeah, it is a good question. I mean, I wonder if they're just blue at this angle, or who knows. But yeah, they are pretty dark though, wouldn't you say? I mean, if you look at this picture over here, it is pretty dark.
Yeah.
Yeah, we will be talking. I think it's next topic, 8.2. We'll be talking a lot more about that and like emissivity and reflectivity and stuff like that. All right, so now I want to talk about what is clean energy. Like I'm sure you guys have heard of this before. Clean energy, like it's kind of a buzzword that you hear all the time in the media and places like that. How does clean energy relate to these classifications of energy sources? So this is a website. I'm linking it down here. I don't know if I should put this in chat. I guess I'll link this into chat real quick. Uh, I need a second monitor. Unfortunately, I don't have one. What am I? No, I just want you to link the text, dude. Copy, link to paragraph. Is this going to work? Oh, what? That's not it. I have no idea what I'm doing. I'm giving up. But when I'm done with this video, I'm going to post this file for you guys. And then all these links should be clickable if you want to go back and check them out. All right, anyway, so this website is energy.gov. And it's a cool website. It lists all the different types of clean energy. And so I have a few questions. So as we're looking through this list, um, keep these questions in mind. What makes an energy source clean? Are all clean energy sources renewable? And what are the limitations of clean energy? So given what we just talked about in terms of which were non-renewable and which were renewable, let's take a look at these lists and think about this. So what makes something clean? Are all clean energy sources renewable? And what are the limitations of clean energy? All right, so here are what the government's website, the US government, is classifying as clean energy. So solar, obviously. Then we got wind. There's water, geothermal, bioenergy. We didn't actually get that on our list, did we? So what is bioenergy?
I
It's
think
energy we
basically
get.
just sort of like, don't you like recreate the human digestive system to some extent, where just like you take a bunch of like you just grind down plants and biomatter and turn it into energy.
Who else is going to talk? Nice, Joel.
Sorry.
It was just the energy that we gather from plants through. Brain, why are you failing me now?
Yeah, like farming and agriculture. Yeah,
Yeah, I would just guess converting biomatter to energy.
there you go. Yeah, converting biomatter into energy. Sure. I mean, it's like what we talked about earlier with wood. Um, wood, like we put wood into non-renewable. But what if, suppose you had a tree that could grow in like a week? Like imagine that. Imagine trees grew in a week. Then where would you put trees? Where would you put wood if a tree could fully grow in a week?
That'd be renewable.
It'd be absolutely definitely renewable. So there's different types of grass. Like I think it's called like switchgrass. There's also like different types of plants that can grow crazy, crazy fast. Like they're just super, super fast growing. I mean, like just think about here in Kansas, like how quickly if you don't mow your lawn for like a week, like holy crap, there's like all this plant matter out there. You could just grow that stuff and then burn it, and then that would be a renewable source of energy. It's interesting that they've listed it as clean. I'm not so sure that that's clean, but all right. And then they put nuclear as clean, and then that's a big
Which
like,
is not.
what? Nuclear is clean?
It's pretty clean until it stops working.
And then they list hydrogen and fuel cells. What do you guys know about hydrogen and fuel cells?
We use them in rockets.
Yeah, we do. The big idea with hydrogen and fuel cells, first of all, is that renewable or non-renewable hydrogen fuel cells?
Non-renewable.
Yeah, it's non-renewable. So you have to get it from water. So the idea is like you take water H2O and then you electrolyze it, which is where you split it apart into hydrogen and oxygen. Now doing that requires energy, so you have to add energy to it to do that. And then once it's apart, what happens if you bring them back together again? You can get that.
It makes an outburst of energy.
There you go. You can get that energy back again. The issue though is how are you putting in this energy to split it apart? Where are you getting that energy from? If you're getting it from a clean source of energy, then this is very clean. But this is almost like a kind of like a battery. I think of it like a battery. I'll put that in quotes, but it's almost like you're storing this energy that you used up here to split the water apart. You're storing it in this hydrogen oxygen form, and then you can bring it back together again and get all that energy out. And the only thing that's coming out is clean water. So if you run a car off of this, and there are cars that run off of this, I believe Toyota has one called the Mirai or something like that. But hydrogen fuel cell vehicles, this is what they do: is they take hydrogen and oxygen, they combine it together. You get the oxygen from the environment. So all you got to do, like from the atmosphere, so all you got to do is just carry around the hydrogen in your tank, and then you stick them together, and then you just make water, and then you drive around while making water, which is pretty awesome if you think about it. The question though is, where are you getting that energy initially that's splitting apart the water? If you're using solar, that's awesome. If you're using fossil fuels, well, then this is just as dirty as the fossil fuels are. Although this is a more efficient process, so I shouldn't say just as dirty, but you obviously wouldn't want to be making that energy from fossil fuels. All right, so let's answer these questions. So, what makes an energy source clean?
Like limited to no emissions.
Anyone else?
Like stability, like they're stable.
Putting question marks just because I want you guys to jump in and share your thoughts.
What do you mean by like stability?
There's, I don't know exactly, but like it's more reliable than burning like I feel like solar power is slightly more reliable than burning coal to heat up water to turn a turbine to get electric. I just feel like there's less steps involved in clean energy, so it's cleaner just in process.
So like easier?
Easier, less things to go wrong.
I'm having trouble writing at this angle. The angle that I have to hold my surface at so you guys can see my face is awkward for writing. I like what you guys came up with, Jordan. I really like what you talked about. I never thought of that before. But yeah, I definitely think that's true. Because if you think about, what's the is solar power really clean? I mean, manufacturing this stuff has a cost to it. Like manufacturing these solar panels, like there's like chemicals involved in it. You need to like extract the resources from the ground. Like, is that really clean? And if you have a source of energy that doesn't have a lot of this overhead cost of like all this like you know materials that go into processing it, then yeah, like it's going to be a lot more clean than something else that has a higher overhead cost. But yeah, I do agree with Joel though. I think it all comes down to emissions. Like that's literally what we mean by clean. Now the thing is like clean, you'll notice I'm putting it in quotes because it's not really a scientific term. It's kind of just like this colloquial like buzz term that people use when talking about energy. But it is about the emissions. And what in particular, what emissions are we really talking about here when you hear the word clean?
Like carbon dioxide, carbon
Green,
monoxide type of thing.
yeah, greenhouse gases.
Yep, greenhouse gases. GHG, greenhouse gases.
Would it be fair to say that like the light reflected off a lot of solar panels that burn birds up in the sky are considered emissions?
What?
Like in
I
California,
don't think that happens.
when I was driving through San Diego, they had a couple of these enormous fields that
Yeah,
reflected light into a central pillar, and that
yeah.
pillar was like almost as bright as the sun, and I'm
hmm
sure it's very hot. Would that be considered an emission or a byproduct?
So that would be heat exhaust, right? Sure. I mean, you could call that an emission, but it's not going to cause global warming or anything like that.
Right. I'm just talking about in terms of technicality, I guess.
Yeah, I see what you're saying. So I would say like the focusing that heat, or I shouldn't say heat, but focusing all the solar radiation to that one point is then boiling water. And so you have a more efficient energy conversion process in that. Whereas with a coal power plant, you'd be burning coal to boil water. And so that's the whole idea here is like you're able to get more efficient production. But yeah, heat is always an issue. Heat loss is always going to be a problem when you're generating electricity. But it's not a problem that's going to be, raising global average temperatures or things like that or causing large scale catastrophes. But you're right though, like heat is something to consider because even if we switched entirely to clean energy, if we produced enough clean energy, it would still itself from the heat that we release would warm the temperatures of the earth. But we're nowhere near that level of energy production. But you're right, is that eventually we won't need a greenhouse gas to overheat the planet. Our heat exhaust would be doing it for us.
Well, wouldn't that heat already be like in terms of like the reflection from the solar panels? Wouldn't that heat already be in the system? Like it's not like
You're right.
we're not making heat.
Right, it's coming in from the sun, so it's yeah, you're right. But I'm thinking more like with other things like fossil fuels and stuff like that, or nuclear. Like if you're burning all that heat, so nuclear is clean because it doesn't have any greenhouse gas emissions. But if we had like a planet full of nuclear power plants and they're all running continuously, we would overheat the planet just by the heat that's released through that process. If that makes sense.
Uh,
Would it be like at a rate comparable to the stuff that's happening with carbon emissions?
Yeah, I mean, I can't really say. It depends on at what scale we're using it at. But you have to realize that even if we do switch over entirely to clean energy, there will be a limit to how much energy we can actually produce because our heat wastes would be enough to warm the earth as well. So just something to consider. I mean, that's like a way overhyped, like extreme situation. Like we wouldn't ever get to that point like within the conceivable future. But I'm thinking like 1,000 years from now, if we have all these like advanced energy systems, that will be a problem that we'll need to think about. So you'd want to probably offshore in the sense of putting that stuff on the moon or something like that. All right, I want to talk about coal. I have 3 minutes left. Damn, you guys are asking. We're having such good conversations here. I'm not even like through everything. I want to talk about coal. So, if you don't know how coal was formed, here's a little picture that I stole from the National Energy Education Development Project. So it just talks about how coal is made. So basically, you go back 300 million years ago to swamps. So there's like these massive, gigantic plants, and the plants die in these swamps. And in over millions of years, they get buried under layers of water and dirt and like smashed and pressed down into the ground. And so all this heat and this pressure basically turns these dead plants into coal. So it's a lot of people think it's like dinosaurs and it's plants. The plant matter is what's turned into coal and like gasoline and things like that. It's not really so much living things. It's the plant matter that did it. So I have a question for you guys. Suppose humans were to exploit all of the coal currently available and we switch to using other energy sources. So we used up all the coal and we're like, let's switch to solar. And so we stopped using coal. Would a hypothetical civilization 300 million years from now have any coal available to them?
Presumably, the coal would have refilled with the currently living plant matter.
I don't believe so because it would take multiple like world-changing events. Like somehow all of the land that we had would have to go underwater where we had tons of plants, and then we also would have to us humans would have to like stop removing the dead plant material from like the earth, like using the trees, using the wood and all of that. We'd have to minimize how much we use there, and otherwise we would never be able to get the coal back to the level that it was, and maybe we wouldn't have enough coal at all, or maybe there wouldn't be any coal at all
Well,
if the pressure wasn't right.
well, those Earth-changing events definitely will happen. It's not like just because like humanity exists so that the Earth is suddenly going to stop shifting around. You know,
I mean, we're going through. I'm sorry, Alex. Continue.
the continents are not stuck in the current place that they are. They will continue to shift.
I feel like it's important to really talk about the term world-changing events. We're in one like right now, and the amount of people it's killing who are going to be buried are going to be a part of the coal production in the next million or so years. And they're going to find a bunch of coal during this like generation of rock formations down when they dig because of earth changing events like this one we're living in right now. I don't think it's unreasonable to say that the people dying from COVID will be coal in a couple million years.
Good talk, guys. So my question to you guys then is this: is coal a non-renewable or renewable energy source?
Depends on the time frame you're looking at. Like if you're some sort of a mortal being with like living over the span of hundreds of millions of years, then yeah, definitely. But for us, with our limited time of around 100 years, no, definitely not.
Yeah, that makes sense. I like that. My clock just went off. I just ran out of time. So how about this? If you guys want to just stop the video here, that's fine. But I'm gonna keep going because we're having a really rich discussion here. But if you guys want to stop here, you can check out. You are not obligated to watch any more of this video. Yeah, so that's something cool to think about, right? Like, depending upon our view of time, like the human lifespan is what sort of classifies something as renewable or non-renewable. It's like coal, technically, over millions, hundreds of millions of years, will replenish, but which is not going to happen in our lifetimes. And so we call it a non-renewable resource. But if you're some like, millennia-spanning civilization, like that, you know, goes from planet to planet to planet to planet, and then every 300 million years you come back to Earth again. Yeah, that would be a renewable energy. Like that'd be a renewable source. So that's interesting to think about. I want to show you guys this graph. This is a cool graph. So this is U.S. coal production from 1870 to 2018, and I want you guys to notice over time, right? There's like this general increase in our coal production as our energy needs have increased. But look at the last, you know, 10 years or so. Look at that. What do you see?
Freeze it up all the coal, and we're finding newer sources. It's a mixture of us using less coal and there being less coal for us to use.
So how many years do you think the USA has of coals remaining, of coal remaining
I give it 25.
at current use? 25. What else?
30.
30. Your minds are gonna be blown.
We probably have a large amount of years left just because of the vast. Because since we haven't been using coal all that long,
Yeah,
we've
Wait,
used small
what?
pockets of it, so we probably have like 1,000 years of
Guys, you
coal.
put
Were you
1,000.
talking about wait, were you talking about when we're just gonna run out of coal or when we're gonna move away from coal?
When do you,
when we're
yeah,
gonna run out.
how many years of coal is it estimated that the US has buried in the ground, like in our reserves?
Yeah,
We have
like
1,000.
if this bar flatlined right there and we kept using it at that rate, how many years would we have left?
Yeah, right. Like if we kept going, I think actually it was up here. The estimate that I read was back in the late 2000s. So if we continued at that rate of producing coal each year, the USA itself would have 1,000 years left. So just the point is like there's a crap load of coal, and people don't really appreciate how much coal there really is out there. Okay, and I was gonna also show you guys this. So this is kind of funny. So, oops, I just threw my pen across the room. Oh God, I still throw my pen even when I'm at home teaching. I want to show you guys this graph. So it's funny because this huge crash that we've seen recently came under one particular president of Obama. And so there's a lot of like people freaking out, like, oh my God, Obama like hates coal, and like it became like this really like hot button political issue. Like Donald Trump like ran on it as like a election issue. He's like turned it into like we're gonna bring back coal and all those things. But this is actually a really cool graph down here. So this is the cost of generating a megawatt hour. That's a unit of energy of electricity. So in 2010, you can see that coal was one of the cheapest ways of generating electricity. And so we used it a lot to generate electricity. There was a lot of money to be made in coal. Why did that graph crash? Because here's 2016. Look at that huge change, right? So 2010 to 2016. It's such a huge drop. Like solar has just come down to be so cheap, like within the last 10 years. And so coal just can't compete anymore. It's the most expensive it's the most expensive way to generate electricity now. So obviously, coal's going to start crashing in a capitalistic society. What are your thoughts on
What
that?
what advancements were made in 6 years that made solar energy so cheap?
So the main reason that I know of is that China started producing just a shirt load, to avoid swearing so I don't get demonetized, a shirt load of solar panels dirt cheap, and they just started spreading them around the world. So they just started mass producing solar panels. That was the main thing that lowered the price.
So the main thing for reducing carbon emissions is relying on China to decide to not use coal. Excellent.
Yes, that's correct.
Oh, great. We're screwed.
You know, we were just watching a video the other day in one of my other classes about how one of the Chinese, I think it's like, I don't remember the name. I'm not going to pretend to either, but they have like huge traffic jams of coal trucks every single day going for miles,
Hmm.
and the coal industry is not slowing down there. So I
No,
don't know.
right. So the thing is that these cost effects, like economic forces, they're really powerful, but they also have a time lag. It takes like 10 years to build a power plant. And so what you're going to see now is that 10 years from now, there won't be any new like coal power plants being made for the next 10 years. No one is going to have any incentive to invest at all in coal because it's just so expensive. And so you're just going to slowly watch these fossil fuel sources just kind of die away as wind and solar begin to get so cheap. I mean, this is 2016. You go to 2020, it's even lower. So the idea is like we're so low down here now with these renewable energy that from an economic point of view, it is more effective and more money making potential if you create renewable energy plants. So you will probably see in your lifetime, like when you're my age, we're going to see a huge shift to renewable energy just
Yeah.
because of the cost.
And hopefully, with all this this COVID stuff and the fact that the blue skies are actually returning to China, they'll take some incentive in using clean energy. I hope.
Yeah, I hope to.
Why did
Uh,
solar move so fast, but like wind didn't?
that's a good question. Let me see if I can. I have to
Wind
go
was
back to
already,
where I before I deleted it.
wind was
Uh,
already cheap.
Strong pushback in rural communities to not have wind turbines built because I was going through last week and I was going through the rural part of Kansas and there were signs everywhere about no turbines.
Mm.
Like
That's
on
hilarious.
people's
Turbines
yards
are
that they
not
don't want
that
turbines.
great.
Well, and our president thinks they cause cancer, so there's that.
Well, he's a moron, but oh well.
I remember my siblings live in a small town in
Demonetized.
Illinois, and some millionaire built like 7 wind turbines that sit on the outside of their city, and they put all of that funding towards their school. Like all the
Oh,
money
that's
that they were
awesome.
making from the wind turbines, they were
I
putting
think
it
I
towards the local school system.
I read something, and this is probably not correct, but it's ballpark that you could get like 35,000 a year from just a wind turbine sitting in your property, like a farmer.
Yeah, it was like the amount of like because I visited back in like 2010 and then I visited now. The amount of change that happened to that small town because of the the wind turbines being there was immense.
Right. So I think that's there's another graphic that I made. I'm gonna see if I can find it. I posted on Twitter a while back. Energy production, which just it like shocked me. Let's see if it's in here. It's not in here. Damn it. Where did I put it? Oh, probably I put it in here. Let's see.
I don't know, man. I think turbines are the coolest part of driving through western Kansas, especially at
Oh
night,
yeah.
seeing all those red dots blink at the same time.
So I made this graph a couple months ago, and this is the renewable energy generation as a share. Let me move my webcam of total net generation. And I was shocked that Kansas is up in the 60%. That 60% of our electricity generation in Kansas is renewable right now, which is just blowing me away. But you can see like this is a huge shift. Like just in the last 10 years, there would be hardly any green. Like most of the country used to look like down in the south down here. Like that's what most of the country used to look like. And now that we're starting to see all this green everywhere, it's really awesome. And this is just a direct consequence of the cost dropping for renewables.
That's kind of what it's kind of frustrating though that like so many states are still like lagging behind on that, especially like the eastern northern states like
Oh yeah,
Maryland and Pennsylvania and Connecticut and all
this
those.
uh this
All those.
divide troubles me a lot. Kansas Missouri divide. Like, what the heck, man? Like, we're not that different. Like, what's going on? Like, why don't you have Missouri? Come on,
I feel
jeez.
like it. I feel like the reason the upper eastern states don't do it as much is because they don't get as much wind because the Appalachian Mountains. Like there's just less energy there to be had, except for
Right.
Maine apparently, which is just lit up.
Yeah, Maine and Washington, I think, and Vermont, they have a lot of hydro potential.
I think it's
I
funny.
was
All
gonna
of
say
the
about like
old
Vermont is actually like near 100% for its renewable because of all the hydro potential.
It's because like 6 people live there.
I think it's funny. All of the states that fought in the Civil War mainly were all non-renewable energy sources.
Oh, interesting. I'm gonna stop recording because this is going way too long. But if you, we don't have to leave yet if you don't want to.